Okay, so let's take a look at example 3, which tells us to express each of the following as a mixed radical in lowest terms. Okay, so the first example A, we see that we have an entire radical, and in part B, this is a mixed radical, but they just want us to maybe simplify it a little further. Okay, so let's start with part A and start from there. Okay, so like what we did before, when we converted the square root of 12 into plus or minus 2 times root 3, well, we had to identify a value that when we broke it down, at least one of them was a perfect square. Okay, so we're going to do the same thing. So let's think in our heads what perfect square value can be divided nicely into 72. Well, I think the best one I have is that, well, I know that 72 is equal to 36 times 2. So I'm going to write that down because I like the fact that 36 is a large number and it's a perfect square and it divides nicely into it. Okay, so the square root of 36 is plus or minus 6. And with that root 2, which we cannot simplify anymore. Now, some of you might be thinking, how did I know to use 36? What if I wanted to do, let's say, for example, square root of 9 times square root of 8? Now, because, square root of 9, that's also a perfect square number. You could technically do that. It's just that when you do this is what happens if you decide to take that route. Okay, so the square root of 9 is plus or minus 3, but the square root of 8 here, this is not the most simplified, because if you think about 8, can it be broken down by a value that is a perfect square? And the answer is yes, it could, because 4 times 2 equals to 8, and 4 is a perfect square. So you know what? We are going to break that 8 into the multiplication of square root of 2 and square root of 4. Okay, so this square root of 4, we know that, okay, so I'm going to keep these in brackets so that we know there's multiplication between them. That's going to give me plus or minus 2. Okay, and so next, when we're multiplying all this, well, this is easy because 3 times 2 is 6. And you can also, multiply its opposites, and that will give you minus 6. So the negative 3 times positive 2, for example, that will give you negative 6. So that there's only two outcomes for this, plus or minus 6, regardless of how you multiply them. And that will still get you the same value as what we got before. So not to worry if you can't think of what is the biggest value that can break down, let's say, the 72. You can also use smaller numbers, and then just, it will take you a little longer, but you will get there eventually. Okay, now the next question in part B is asking us to simplify this mixed radical, which is 5 times root 27. Okay, so the 5 I'm not really going to deal with yet. It is the square root of the 27 that needs some massaging. Okay, so this 27, this has to be broken into the multiplication of two values where one of them has to be a perfect square number. So think in your heads, what number multiplies to 27 and one of them has to be a perfect square number? Well, that will be root 9, right? Square root of 9 times square root of 3. So square root of 9 is plus or minus 3, right? Remember, there's still multiplication between each of them, so don't forget that to put brackets here, because if you don't put brackets, you might confuse yourself with 5 plus 3 or 5 minus 3, which will get you a very different result. So doing that, so multiplication of the 5 and the plus or minus 3 will give me plus or minus 15 times 3. Okay, and so at this point, I'm looking at my answer. I'm trying to see, can I break down the square root of 3? And the answer is no. Okay, so that has been simplified. In example 3, they ask you to simplify. Okay, so what that means is you have to take each of these expressions and you have to rewrite it in such a way that it looks cohesive, that if there's things that we need to reduce or to put in lowest terms, we have done that. Okay, so we're going to walk through these examples to show you how that is done. So square root of 5 times square root of 11 is going to give me the square root of, well, we're multiplying them, so that's really straightforward. That's the square root of 55, okay? So when you multiply that, you get an entire radical. Is there a way for me to break down like 55 into the multiplication with a perfect square? No, there's no perfect square that multiplies to 55. So in that case, that's done. Like, I cannot do any more with this. Okay, now on the other hand, when I am working in part B, well, look what we have here. We have two mixed radicals multiply to each other. So we're just going to multiply it the way we normally multiply numbers. Okay, so negative 4 times 2. What is that? That is negative 8. Okay, so that's the first part. Now you got a root 6 times root 6. So what is root 6 times root 6? Well, that will just give me 6. So I'm going to put these in brackets to indicate that we're still multiplying. So this is really negative 8 times 6, which gives me negative 48. Okay, and in part C, here's a different example where, so before what we've been doing in part A and in part B is that we're just multiplying them. Okay, now in part C, we're going to use them. We have different operations, which involves a minus and a plus. And this is kind of like a chapter in grade 9 when you had to combine like terms. Okay, so remember, so if let's say I had 2a minus 7a plus 1a, or just a, well, we know that these are like terms, right? Because they have the same variable, same exponent, which is 1. And so you can combine them. So that means, so 2 minus 7 is negative 5, plus the 1 will give me negative 4. So that's negative 4a. So what we're really doing here is kind of like what I'm doing with the like terms, okay? We're going to treat that a like as if it was a square root of 3, or we're going to treat the square root of 3 as an a. And because they are the same, we can combine them like we would do that with like terms. Okay, so 2 minus 7 plus the 1, well, that is going to give me negative 4 square root of 3. Okay, so you can actually treat radicals when they're the same like as if they were variables, and you're combining them like terms. Now, part D is I'm going to try to add the square root of 50 plus square root of 200. Now, these are clearly not like terms, okay? So we can't really do that. But what if we can break down these individual radicals into something that is more simplified, and hopefully that can combine into something? So why don't we take this square root of 50, because we can actually turn that into a mixed radical, right? Because we know that 50 is 25 times 2. So I'm going to write that right now. So that this is square root of 25 times square root of 2, okay, for that 50. And for this part, the square root of 200, I'm going to break that down into the square root of 100 times square root of 2. Okay, I hope that people can start seeing something that is really cool and very like termish in this example. Well, okay, before I get excited and start combining things, I'm just going to rewrite all this, okay? So the square root of 25 is going to be give me plus or minus 5. And so I think for this particular example, because when we take the square root, I know there's a plus and a minus value. We are just going to deal with the positive for this particular one. So if there was a question like this, work with the positive. So this will be 5, positive 5 square root 2 plus 100 square root 2. Okay, so, oh, sorry, not 100. It should be 10. Okay. Whew, okay, fixed. Okay, so now you have two radicals here that are the same. So it's kind of like part C in the sense that we kind of like treated these ones as like terms. So these two are my like terms. Okay, so we're gonna just do 5 plus 10. That's gonna be 15. So I got 15 root 2. Okay, so next example, E. I'm going to break down this square root of 48 into the multiplication of two things. So what number multiplies to 48? That one of them is a perfect square. Well, that will be 16. I think 16 works. 16 and 3. Okay. It's always a good idea to try to aim for a bigger number, because when you aim for a larger value that is a perfect square, you end up not having to reduce more. Just like in this example where I purposely picked the 36 because it's a bigger number, and so that like skips a lot of steps. If I, let's say, didn't do that, I would have to break down more things. Okay, so it's always a good idea to try to break it into something that's bigger, because yes, technically you can do 4 times 12. That also works, but then that square root of 12 means that you have to break it down further. Okay, so for this example, I'm just going to do root 16, and for the square root of 75, well, that is the square root of 25 times square root of 3. And I think a light bulb is coming onto most of you right now, where you see that, oh, look at this. We have the same radical here. Okay, so we are going to take the square root of 16, so that is going to be equal to 4 times root 3 minus 3 times 5 times root 3. So we're almost done. So that's 8 times root 3 minus 15 times root 3. So that gives me negative 7 root 3. Okay. And last but not least, we have a question where you have something like a FOIL thing that is going to happen, right? You got a binomial here multiplied to another binomial. Now, the square root of 24, I am first going to break that into a mixed radical. And I'm not going to multiply them. Like, I know that like FOIL is something I will do eventually, but there's a reason why I'm going to break this down. Now, I want to show you why that is the case. So 24, what number multiplies to 24? So we can do 4 and 6, right? Yes, that works. So we can turn this into square root of 4 times square root of 6. Okay, and then from this point, we could well, we know that the square root of 4 is, it is 2. So I am going to rewrite that like this. And now I am going to FOIL it. Okay, so the first term, so 3 times 2 is going to give me 6. And then outside, 3 times 2 root 6 is going to give me plus 6 root 6. Inside, it's going to give me minus 2 times root 6. And last is negative times positive, so that's going to be minus 2. But look what we have here, root 6 times root 6. You could write root of 36, but you know what? I know that root 6 times root 6, well, that is just, good old 6. So we're going to do that. And now, look what we have. We have something that we can work with because, look, the 6 and this 12, right? This is a minus 12. That can go together. And we got the 2 root 6s that also can be combined also. Okay, so at this point, we're almost done. One more step. So 6 minus 12 is negative 6. And you have 6 minus 2, right, because we're collecting like terms, right? That will give me 4 root 6. Okay, so this is the final part of the video. I'm done pretty much 3.4, and I hope you enjoyed it.